Cool. Don't worry, that's not the actual title, but it is descriptive. So this lecture, we're gonna speed through things a little bit, and it also is quite difficult. I said in the title of the presentation, maybe interfaces. We won't be covering interfaces today because I think that would amount almost to abuse, because honestly events and delegates are hard enough. But yeah, I mean, it's also quite nice because we'll be able to see how things are done more formally, and really see why object-oriented programming is as powerful as people say it is. Okay. So yeah, that's the actual title of today's lecture, Memory and Events. And the reason we say memory first is because we're going to have to learn a little bit about how memory works in C# on a slightly more basic level than what we've seen so far. So we've done some simple examples of memory, like when we went through that while loop step by step and we had the memory in the bottom left. But that wasn't technical enough, so today we'll cover slightly more technically. That's not the difficult part of the lecture though. The difficult part will be events. I'm also going to try out another thing. So on Rex Tester there's this code wall, okay, and it's actually quite interesting. So it just has a bunch of publicly available code bases, I guess, if you want to call them, for different programs. So I'm going to we're going to be writing a lot of code today, and I'm going to release that code on a Rex Tester code wall, so you'll always have access to the code that I write today. I mean, if you are able, then do continue copying through by yourself, okay, because that's also obviously beneficial. And yeah, feel free to post questions. Yeah, the big thing about this whole online learning thing is, you have to be proactive about interaction, okay. But yeah, let's jump into memory. Yeah, I'm even nervous about your learning this lecture, because this stuff will be interesting. So before we go into memory, the only way we can really express it properly and explain it properly is if we first go over methods again. Now for some of you, I'm sure you're going, oh come on, I know methods by now, but we are going to create one more method just to really finalize our understanding of this. Okay. So hopefully you remember this example from a while ago. Okay, public static void main. We had this function that was just squaring things, right? So it took in a number. In this case, that number was x, and it just multiplied it by itself, and then it returned it. Okay, so what I would want you to focus on here is we have two functions. Particularly listen to the words that I'm using to describe what's going on here. Okay, because I'll use new words this time to what I've used before. So we've got two functions, main and function, okay, or two methods, whatever you want to call them. Okay, specifically, main is calling function. Okay, that's what we call it. It's calling it. So when we say function x like that you could say main, the main method, is calling the method function. Okay, and you can see it's like, hey function, please multiply this number by itself and give that back to me. Okay, it's calling it, asking it to do something. Alright, it's also another word that we must learn, passing something. Okay, so int x equals 3, there we create this variable, and in that function call, where main calls function, we have that x. Okay, it's got a red square around it currently. Function x. Okay. Ooh, wait, there was a nice thing. It's quite cool. Check the little laser pointer. I prefer that, I think. Anyway, so you see it's got the little red square around it. Okay. The word I'm going to use to describe this is main is passing the variable x to function. Okay, and in function it's called a, that's irrelevant. The point is something is being passed to function, and that's the word we use. So it's passing the parameter to function, the parameter x or the variable x, whatever words we want to use. Right. Awesome. So cool. let's maybe program up this example quickly because we'll use it, or maybe we'll make it do something different. Does anyone have any ideas? Maybe we can add the number to itself this time instead of multiplying it. I don't know. Okay, so I'm going to create a second method, and it's just going to take in a number and do something with it. Alright, so we'll say public, yeah, I'm going to make it static, okay, and we're going to say, for now, let's make it return int, okay, because it's going to be returning a number. And we're going to call this method my method. Alright, my method. Okay, my method. Then, what do? We create a number, okay, int x equals 6, for example, and I just want to say my method on x, okay. How will it allow me to do this? What's wrong currently is my method is not accepting any integer, right? So when we create a method, we have to say whether it's public, whether it's static. Hopefully you remember what this word means. It's not the biggest of deals, but basically it just means that I don't need an object to call this method. Okay, I don't need an object to call this method. And then we give the function a name. We also have to specify what it's returning with int here. And then inside these brackets, we tell it everything that it should expect. Okay, all of the variables it should expect to be passed and what it should call them. So it's going to be passed one integer, and it's going to call it a. Okay, and then you can just use that integer inside the method. Okay. This is expecting to return an int, so let's make it return a plus a. Right, so here we would expect this to become this to return 12. Okay, return 12. And to see that, we'll go console.writeLine my method x. Okay. And you can see when I write that, as hopefully by now you guys would expect, it's just going to print out 12, alright, assuming I didn't make any mistakes. Yeah, prints out 12. Okay, so we've set up a basic example of a method here, and this method in particular is one that returns something. Okay, it returns something. Okay, to explore this concept of memory, I am going to stop returning things. Okay. But let me first, yeah, I think let's go to the slides first because they probably will explain it better than I can in words. Okay, so in our exploration of memory, we're going to think about two concepts. Okay, two important concepts. Pass by value and pass by reference. Okay, you won't recognize these phrases yet, and you don't have to worry about that. You should know what a value is, though. Right, so variables can take on a specific value. Okay, so this pass by value one is what we're used to when thinking about methods, and so we're going to start by focusing on that. Okay, so let's not think about pass by reference yet. So I'm going to represent memory in the bottom left here. Obviously this is not a literal depiction of memory, but the idea that this is trying to convey is that there's a memory location 0, okay, hash 0. So this is just an address. You can think about it as an address in memory. Okay, so something is stored at that address. Something takes up that address. We're going to say that's just a browser or something. Okay, it's just any application that's running on the computer, your operating system, whatever. All of these things have a place in memory. Okay. We're going to say position 1 in memory is taken up by our main method, all right? And again, it's not literal. There'll be a place for the function method, the class, all of these different things will have their own place in memory. Those we don't care about yet. Okay, so I want you to focus on memory at address number 2 and at address number 3. That's really going to give us the difference between pass by value and pass by reference. And if I'm going too fast, please do ask questions, okay? Because it's going to be tough to some yeah, this is a bit of a difficult concept. Okay, cool. So focusing on address at number 2 and number 3. Okay, so we've let me maybe quickly go back to the code example just to show something. So we can see x is passed to my method. Okay, in this case, our integer x is passed to my method. Okay, here, and you can see it's given the x there, and my method expects it and it calls it a. Okay, so what we're thinking about is, how is this actually happening? Right? How is this actually happening? What is the computer doing behind what we can see here? Okay, that's the idea that we're exploring. How is this passing of this variable actually occurring? And what I'm telling you is that there's 2 ways for this to occur. All right. So this first way, the way that we're currently looking at now, we go, okay, we create this number, all right, int number equals x. This is now in here, right? Int number equals x. We create a number. What happens when we do this? Okay, these little black dots that were after the number 2 and the number 3, that's saying this place in memory is empty. It's an open address, okay, ready to be moved into. All right, so this is just an empty memory location. So when we create int number equals 6, the computer goes and it just goes, okay, this piece of memory has this thing that we're calling number, and all it's saying is, look, number points to this value. Okay, it points to this value 6, and that's what we call it. 6 is the value. All right, so now we've just got that memory address. It's no longer empty. Okay, it's taken up by number, and we don't care at this point how the computer is representing that. I just want you to see that it's got this place in memory. All right, cool. Next, we make the function call. Okay, so I call function number. Okay, function number. Now, how the computer actually does this, you don't necessarily see it, but what the computer is actually doing is it goes, okay, I don't give this. You see, number has an address, and you might think like, okay, it's passing number, so maybe it's passing this actual address. That's not what it's doing. Okay, it copies it. All right, it copies it. So it'll go to the next open place in memory. So you see number 3 was empty. When we make this function call, it goes, okay, number 3, you are going to hold a copy of number. Okay, a copy of number, and its value is 6. Okay. So this copy, this is what we actually pass to function. Okay, that is what we actually give to function. This is what function is working with. All right? And for the first question today, it's, what does this mean in practice? Okay, and that's what we're going to use that's what I'm going to use this example to show you. Okay, so the fact that we make a copy of the variable that we pass to the function, we don't pass the actual variable, if you like. We don't pass the actual location in memory. What does that actually mean for how we work with these methods? Okay, so sorry about that. Okay, so that's the question that this first example is set out to explore, right? And I hope you guys are comfortable with that. All right, so how we're going to explore this and to see what this means in practice, I'm no longer going to print out my method x. Okay, I don't care about what my method x returns. In fact, we're going to make it return nothing. How will I do that? Just to get some engagement going, what does that int have to be changed to in order to make that method return nothing? Anyone post in the chat, what does int have to be changed to make my method return nothing, to make the computer okay with it not having a return value? Anyone? Void. Great stuff. Yes. Okay. Good. Sorry, I do have to confirm that you guys are awake, right? So, cool. So we So we're in my method now, right? So int x equals 6. So to show you that it is passing the value, let's just clear that up first, okay? So what I've told you now is it takes x, it makes a copy of it, and it saves it in A, and that's what it gives my method. A copy, a new memory location with that value. So we can see that if I go console.writeLine A, this should print out 6. Alright, so when I run this, and when RexTester eventually runs it, we get 6, okay, as we would expect. So we didn't change A at all, and we just made a copy of it and then printed it out. Alright, comfortable with that idea? So it's 6. Okay, but now to show you that it is a copy, okay, in my method, okay, we passed it x. I'm going to say A equals, let's say A plus A. Okay, A plus A. So actually, you know what? Let's stop with the plus thing. A times A. Squaring just is an actual sensical function. Okay, so what have I done here? I've changed A to be A times A. So now we would expect 36, right? A must hold 36. And I'm going to print it out here. Okay, console.writeLine A. Okay, console.writeLine A. So what's happening now? We call my method, we pass it our variable x, and that the value of x is 6. Okay, as we said on the first line. It's copied and it's saved in this variable A. Then we go, okay, change A, and make it A times A. Okay, make it A times A. So A should be 6 times 6, which is 36. Okay, because this will be 6 times 6, and it's saved in the thing on the left, so it's 36. Console.writeLine A, we print out A, and so when I run this, we want it to print out 36. So you see, A's value has been changed to 36. Okay, so if we pictured that on our slides here, we changed the copy's value to be 6 times 6. Okay, so in memory location 3, we would now have 36, okay, instead of 6. But just, we want to confirm now that number, the thing that we passed to our method, is not changed. Okay, so in our case x here, we want to confirm that that's not changed. So I'm going to go, after we call my method, I'm going to say console.writeLine x. Okay, so you see what happens here. I pass x into my method. We times A by itself here, which is our copy of x, and then we print it out. We print out A here, and then we would come back here and print out x. Okay, so now this prints out 36, 6. Okay, you see x was not changed. Okay, this is it's an important idea, guys. Do you see x was not changed? 36, 6. Do you guys understand that idea? Oh, what page is this on? That's a good question. I should start by saying that. Hey, 46. Okay, so I think their example is maybe a bit hectic though. So number 2 remains the same. Or yeah, exactly. So you see what happened. We changed the copy. That's the idea I want you to grasp. And it's not super complicated yet. Okay, the next bit might initially freak you out a bit, but this idea is fairly simple, right? We made a copy of x. We didn't give it x actually. Okay, we gave it. You see, we didn't actually give it x. Okay, we gave it a copy of x. And how we say that in programming lingo is we say we pass by value. Okay, so we passed the value of x. We did not pass the memory location of x. We did not pass x's location in memory. So my method had no idea where x was in memory. It couldn't change it. Okay, because we just gave it the value. We were like, look, the number you want is 6. The memory location is a separate thing. You're getting a copy of 6. Okay. So yeah, exactly, Vaish. Number 2 remained the same. or hash2, whatever, the location in memory was not changed, okay, or was not updated, I should rather say. Okay, so we understand that idea. We passed by value. Okay, cool. So I hope that's not too hectic. So I do want to show you guys like how you would do this normally before we get into the next thing. So you know how I would change this to go back to returning a, right? How would I want to return a? I would have to say int, right? Not void. So now we're returning an integer, and then I say return a. Okay. So now my method x becomes whatever a was here. So now we return 36, and then I could say x equals my method x, right? And now x would be updated. Okay. So now x would be updated because I updated manually here by returning. Okay. So you see now x is 36. But that's so you can do it that way. So just in case anyone was confused about how we got the value out of the method in the first example, it's because we actually returned it, right? We actually returned it. In this example, we're not returning anything. So nothing comes out of my method. Okay, nothing comes out of my method. And my method edits a copy. A is a copy of x. It is not x itself. Okay, it's A, how we would say that? A refers to a different location in memory. Okay, so here copy is a for us, is a. Number is x. Okay, x refers to number 2, the second location in memory. A refers to the third location in memory. So when we change a, we change this. We don't change this. Okay, I think based on how everyone's comfortable with that idea. Okay, so pass by value. Because if you have more questions, feel free to ask, please. Okay. Cool. So why did we explain this in such detail? It seems a pretty sensible way to do things, right? You don't pass the actual memory location. You pass it a copy of the value that you want to give it. It's the way a human would actually think about this. When you give it number and you change the variable inside function, you don't want it changing the actual number outside of the method because that might be a bit freaky. Okay, so now we have to talk about the freaky one. Okay, ooh, pass. Why did I put copy there? Oh no. There shouldn't be a copy there. I know why it is there because I copied, but you get the idea. There should not be a copy there. Okay. Unfortunately, I don't think that'll update the slide, will it? No. We're going to have to open it again. Presents. Okay. Cool. Pass by reference. Okay. So passing by value, just think about it as making a copy. Okay. So now, what is pass by reference? What do we mean here? Now, remember what term I used to describe this idea here? We could say number is number refers to the second location in memory. Copy refers to the third location in memory. Okay. Notice that word refers. Okay. That word refers. So at a broad level, we'll go through it in more detail in the slide now. Passing by reference is actually passing the memory location. Okay, so before we were making a copy and passing that copy, now we're actually passing the reference location. Okay, the memory location. Cool, but let's see in how I set this up in the example. Okay, so same idea. In the bottom left, we're representing memory. Okay, in the bottom left, we're representing memory. Okay, I say int number equals 6, and this is still exactly the same. It goes ahead and says, okay, the second memory location is number, and that's just a placeholder for 6. Okay, we don't care about how the computer is representing it in binary and stuff, but this is just, at a high level, it goes, okay, the second memory location is pointing to this variable, right? Perfectly okay to word it like that. Now, instead of saying function number, This time we say function, this ref keyword. You've never seen this. I'm sure you can guess what ref stands for. I hope I don't have to tell you, but I will anyway. It's reference. Okay, so function reference number. So now we're passing a reference to the variable, not the now we're not passing by copy anymore. We're passing by reference. Okay. Now what does this actually mean for this? Now we don't. Notice previously on the last slide we opened up 3 here and we were like, we found an empty place in memory. We made a copy of number and we passed the copy. Now because we're passing reference number, we just give it this. We go, look, you're getting the reference now. You're getting the second location in memory. So now when you edit this variable, you are editing number itself. Okay. So that might look quite freaky here, but an example, if you understand what the method is doing, the previous method is doing, you'll be able to see in an example how this changes things very easily. So if you can't picture it yet, don't worry too much, but this is like the high level idea, and now we can go see in our example what this would mean. What if I now pass the reference? And basically it just changes what Vaish said. So now when we pass by reference, memory location 2 will no longer remain the same. Okay. I hope you guys are so quiet because you're concentrating and not because you're either terrified or bored. Okay, so how would I set this up? I have to tell C#, okay, that it's no longer expecting an integer, because if it's expecting an integer then it will expect an actual number. So now I just tell it it's expecting a reference to an integer. Okay, ref int. Not a big change. And then when I call my method, I just pass ref x. So a reference to x instead of x itself. If you want to go into more detail about what those mean, we can afterwards, but I want to run the example when it eventually runs. And now you see the big change here. It goes 36, 36. Quite interesting, right? How specific you have to be. Okay, how specific and sort of careful you have to be. So here we say int x equals 6. We pass it reference to x. Okay, a reference to the variable x. Okay, so that comes here, and it goes, okay, I'm expecting a reference to an integer. So the memory location, the location in memory for an integer, I'm going to call that a. I then go update that memory location to a times a. Okay, so it still updates it to 36 as we expect. But this time when we go back, we no longer changed a copy. We changed x itself. Okay, so this example is just to illustrate what passing by reference does. You will never use it this way exactly, but I found this was probably the easiest way to understand it because it doesn't change much about what we're thinking about, okay? And it shows very clearly, like you see, we give it a reference to x, it expects a reference to an integer, okay? And we literally have to tell it. We say, look, this is a reference. Whereas where this is actually used, you're not telling it, okay? You won't tell it. But I just, for now, do you get what happened there? We now passed the actual memory location. So when we changed it, it changed in main as well. It changed x. It didn't just change a. Okay. Are you guys comfortable with that idea? Any questions so far? Honestly, if I knew this when I was your guys' age, that would be, by now I would be way better at this stuff. Because honestly, learning this before university level is a bit surprising. But do you guys get this idea of passing by reference? Okay, I assume, yeah, no questions. So I assume you guys are on it. Awesome. Yeah, that's good news. Cool. That went over surprisingly smoothly. Honestly, like this, a lot of people get this wrong in first year comp sci. This is considered a challenging question in first year computer science. So if you guys are planning on pursuing computer science, by then you're going to be pretty far ahead, I reckon. Okay, cool. So that's references. This is not how they're used. So the next slide will clarify better. This is not how they're used, but this is the idea of a reference, and you can see it in the code nicely here. Whereas you'll see in the next example, it's not as obvious, it's not as clear that we're passing a reference. Here it's so clear, we say reference number. Okay. In the next example, you'll see it's not as clear, but it's the same idea. Okay, if you understand this, you'll understand the next bit that I'm going to show you. Okay, so yeah, some stuff to note about this whole pass by value, pass by reference thing. Okay, hopefully you remember what objects are. Okay, an object is an instantiation or an instance of a class. Okay, an instance of a class. We've covered objects for like 2 lectures now. Hopefully you're getting okay with that idea. Don't worry, you're going to see more examples just now of what objects are. But what I'm noting here, all objects in C# are passed by reference. Okay, so you give the memory location of the object, not the value. If you don't get that yet, don't worry, we'll see an example of it. Should I show you an example now before I show the next note? Actually, yeah, I think that's probably a more sensible way to do things. Okay, so what does this mean? All objects in C# are passed by reference. Okay, so in order to see that, we're obviously going to have to create an object. Okay, we're going to have to create an object. In order to create an object, we have to create a class, so we can also revise constructors right now. Okay, so this is a nice way we can do both revision. Damn it, we're almost at a break already. I've been going for 37 minutes. What? Okay, so we're going to have to maybe speed up just a little bit. Okay, so I'm going to create a class quickly. To set up the example that we're going to do later, let's make a video class, okay, like YouTube would have. Okay, so a video, our videos are going to be super simple. They're just going to have a title. Okay, you could give them more properties. You know how to create properties. Our videos are literally just going to have a title. Okay, just a title. So I'm going to say class video. Okay, class video. We know how to create a class. That's totally fine. Class video. We need to create a actual property. So I'm going to say public string video name. Okay, simple property. Okay, it's public, so it's accessible outside the class, so we don't need... If it was private, what would I need to create? Does anyone remember what they're called? If it was private, what would I need to create to see it and change it? Anyone? What would we have to create to see and change a private property or attribute inside a class? Don't make me ask you specifically. Getters and setters. Oh yeah, 2 people answered. That's great. Okay. Getters, get and set. Oh, 3 people. Great stuff. Yes, that is correct. If it was private, we would have to create getters and setters. It's public, so we don't have to do that, okay? I'm going to create a constructor. What's the big rule about constructors? They must have the same name as the class. Okay? How many variables is this constructor going to take in? Okay, I just want to set all of the properties of this class. How many variables will I need? Anyone? How many variables will I need, and what will... Okay, I can't say their type will be. What will its type be, because there's only one. Okay, yeah, it needs to take in 1 variable of type string. Okay, to set the video name. So we're just going to say string. I'm going to call it video name. Okay, we learned this trick before. String video name. And then we can say this dot video name to make it clear that we mean the one inside the class equals video name. Okay, so they can have the same name. Hopefully we're okay with this idea. I'm just reminding you what this means. Okay, so this is a constructor. We've seen that before. All right. Now, let's create an object of type video. How do we do that? We need to specify the type. It's a video. We need to give it a name. It's a vid. Okay, video vid, or video, whatever you want to call it. Video vid equals new video, and we have to specify our title. Okay, let's say do some foreshadowing and say exciting new content. Okay, exclamation point. Okay, exciting new videos. All right, video vid equals new video. Okay, and now just to double check that our class is working, we can say console.writeLine vid.videoname. Okay, vid.videoname, and we want it to print out exciting new content, and it does. Okay, now we created that class. I did it quickly, but it's just revision, so hopefully it didn't hurt anyone. What we want to actually see is all objects in C# are passed by reference. So what does that mean? It means we pass the memory location of the object. So I'm going to change my method. It no longer takes in a thing of type refint. It now takes in videos. Okay, so it now takes in a thing of type video, and it calls it vid. Okay, you've never seen a method that does this, but I hope because we've covered what types are, you understand what it's doing. It's taking in an entire video object. Okay, it's not just taking in an integer or a string anymore. It's taking in an object. And what did I tell you? All objects are passed by reference. Okay, all objects are passed by reference. So what am I going to do with vid? Let's say I update video name. Okay, so I'm going to say vid.videoname inside my method. Okay, so my method takes in a video and it calls it vid. Okay, and it just updates video name to new name. Okay, new name. Cool. So if I now go my method and I pass it vid, so the whole vid object. Okay, and then I go console.writeLine vid.videoname. So, bearing in mind that vid objects are passed by reference, and we update video name here, what do we expect this to print out? Will it print out A, exciting new content, or B, new name? I'll leave it until I hear a chat beep. Yes! Yo, okay, you two are on the ball. I'm not sure about everyone else, but you two have got this down. Yes, exactly. It's going to print out new name. Okay, unless I lied to you. Inconsistent parameter type video is less accessible than program.myMethod video. Ooh, hold on. What did I do wrong here? Inconsistent accessibility. Oh, right. Sorry about that. I think that's the problem. Yeah, okay, and it prints out new name. Sorry, I had to make the class public as well. And I was being silly. Okay, cool. Yay, new name. Alright, so you guys were correct. It prints out new name, and hopefully you can see why it did that, okay? Again, the reason I showed you the other example first is because here we didn't say ref anywhere, right? It's not clear, it's not obvious that it's passing by reference, but hopefully now that you've seen that other example, you know exactly what this is doing, okay? It's passing by reference. And if you understand that, damn, like you're in a good place. Like this is a challenging concept, guys. So if you're getting it, that's very good. Okay, cool. And just by the way, I haven't told you this explicitly, I don't think, but just by the way, arrays and collections are also objects. Okay, so you know what an array is? A list. It's an object. It's considered an object. Okay, which means it's passed by reference. Okay, it's passed by reference. So if you change an array inside a method, it will also change inside the main method. Okay, I guess we do have some time to show you this. I'm glad I'm not doing interfaces today, because we would definitely run out of time, because this is taking longer than I thought it did. Okay, so to show you that arrays are also objects. So we know that objects are passed by reference, and we just saw that with our video object. I've also just told you arrays and collections are also objects, just by the way. So what do I mean by that? If I create an array, so like int numbers equals some list, okay, 0, 1, for example. Okay, so it's a list of numbers. Hopefully we're all okay with that. Now I'm just going to tell my method it's no longer taking in a video vid, it's taking in a list of numbers. Okay, so I say int with the little square brackets. That's how we create an array, and we're just going to give it a name. I'm going to call it x's. Okay, x's, lots of numbers, or lots of Elon Musk's son. Did you see that, by the way? He named his son X. Who does that? Okay, so x's. Now, when I change x's here, so I'm going to change x's in x's in position 0 to 100. Okay, x is in position to 100. X is in position 0 to 100. Okay. And you'll see if I print out if I call my method first, so my method, and I pass it numbers. Numbers is being passed by reference. Okay, so when I go console.writeLine, I'm not using the new keyword, but it should be okay. Numbers in position 0. What do we expect to see? Right, it started as 0. I changed in my method after I passed it numbers. I changed x's in position 0 to 100. So what do we expect to see when it eventually does print out? 100. Okay, so objects are passed by reference. Arrays. Oh, yeah, you answered before. That's great. Okay, that means you guys are even confident with this, so that's great. Okay, all objects in C# are passed by reference, and arrays and collections are also objects. Okay. The new keyword is a clear sign that something will be passed by reference. Okay, I just say that. What do I mean new? Do you guys remember where we use new? We use new when we create objects, right? We use new when we create a new object. So that's all I'm saying there. Okay, so if the new keyword describes something, you can automatically go, okay, that's going to be passed by reference. If that ever goes into a method, it's passed by reference. That new keyword is a very good indicator, because the reason we have to say new is because it has to reserve the place in memory. Okay, not too bad. All right, so the new keyword is a clear sign that something will be passed by reference. We don't need to see an example of that, because the first example was that, right? We used new, it was passed by reference. And basically wherever new is used, that's going to be passed by reference. Okay. Normal variables are always passed by value unless the ref keyword is used. Okay. So you've seen that as well. What do I mean normal variables? It sounds a bit weird to say, but I'm saying like int or string or something like that. All of those normal types, those early types that we learned, double, float, all of those are passed by, are there any? No. Just passed by value or passed by reference. You're either passing a copy or you're passing the memory location. There's no middle ground. So that's at least one nice thing. Those are the only two concepts we need to know about memory. So you don't have to worry about any other hidden hidden things. So this is a exhaustive list. Okay. Normal variables are always passed by value unless the ref keyword is used. Okay, so ref just means, okay, pass this one thing by reference. Okay, because you're saying reference it. Okay. And what's cool is this knowledge of pass by value versus pass by reference is, so it changes slightly in other languages, but the same terms are always used. So if you hear someone referring to, in Python, it's usually called pass by copy. Like if these ideas they're identical, so you'll understand them for all programming languages. Okay. all programming languages have this weird distinction. Like some languages will exclusively pass by value, some are able to do both, like C#, but you'll now always understand this idea. Okay, pass by value, pass by reference, what's the difference? And that is a very advanced programming concept. Like, a lot of people will not learn this. Okay, so it's quite cool if you guys have already got that down. I think, okay, let's break in 5 minutes instead, because I think we can maybe do a bit more. Let's see, what didn't we see? This third example I glossed over a bit, right? The third thing in that list there, the new keyword. Alright, actually, yeah, this is perfect in the next 5 minutes. So, why do you say... Oh, right, yes, don't use it. That would be good to point out. Don't use it, but I only showed you that ref keyword because I thought it was a very good early example for showing reference, because you're like saying reference. Okay, I thought it was simpler than showing you actually changing a list without knowing what pass by reference means. But in general, guys, normal variables, you might think you understand what's going on when you're passing something by reference, but a bunch of things can break. Okay, a bunch of things will break. So in general, we don't... Normal values, there's a reason they're passed by value. Okay, normal variables, there's a reason they're passed by value, and just leave it. Okay, don't add that ref keyword. You're going to cause yourself unnecessary trouble. Okay, because if you're now using... If you create a normal integer and you're just trying to calculate... you're just trying to calculate like what the square of this number is, you don't want it changing the like user input or the initial number. Okay, you just use a return statement, right? You use a normal return statement and the method must just return an int. This passing by reference thing is useful because methods can't return an entire object. Okay, returning an entire object gets really weird. Like if you've got you know, particularly hectic arrays or a particularly large object, you don't want to create an entire copy of it. Okay, but when it's just a normal integer, it's fine, just pass it by value. Okay, it's not going to take up much space in memory, it'll be deleted when you're done using it, it's not going to break the rest of your code flow. Okay, so yeah, in general, if you guys eventually do become programmers, it's generally good practice not to artificially make it so that these normal variables are passed by reference, because you're going to break the code and other people will struggle to understand what's going on because there'll be refs everywhere and you have to be more sensitive about whether or not you're editing this just here or in all the code. Okay, but last thing before we take a little break, I want to this will just be to show you that lists are objects. Okay, I'm just going to remove the method thing. We understand pass by value and pass by reference now. I'm going to create a list of numbers. Okay, int numbers equals... Actually, let's create a list of names. String, to show you that this works with other things as well. So string names, that's how we create a list, right? We put some names, because I still don't... I didn't actually hear when you said on the mic. I still don't know who this top of the world person is. Okay, so we've... Okay. Amilcar. Oh, of course, yes, okay. No, I mean, yeah. Now I do know who you are. Okay, so... Cool. Vaish name... Okay, we can... have two. Okay, anyway, this is how I've shown you how to create lists, right? I've shown you how to create lists like this, where you actually specify them manually. What if you don't know what the names are yet? Okay, you don't know what the names are yet. You just know that you want 3 of them. Okay, so you want a list that can hold 3 strings, but for now all the strings are just empty. Okay, how would you do that? Well, this will show you that arrays are objects. Okay, what keyword do you think we're going to be using? Can I ask? I'll answer. Yes, new. We'll use new. Okay, so new, right? String names new equals new string. Okay, and then you just in the second set of square brackets, you just specify a 3. Okay, or whatever size you want the list to be. Okay, and then you can use this exactly like a normal list. Okay. Oh wait, we said it was a list of names, so that's maybe a bit rude. Okay, cool. Name 0, and that will just work now. Okay. Cool. So yeah, that's just what I wanted to show you in the last little bit. That arrays, collections, they are objects. Okay, and so they're passed by reference. Okay, yeah, let's take a 10-minute break. I can answer your question as well, Ethan. Actually, I was working all day on this thing because we're getting a contract soon. But you guys will get bored of this because I'm going to use our little Scrum team that we have going here to... Actually, yeah, I got this working yesterday. Finally, this actual URL should work, I think. Actually, but this will be a good test. Yes, it works. That's so lovely. Oh, that was so difficult to get working on AWS. But yeah, that's what I've been working on lately, Ethan. A little startup. But like I've done some. Yeah, well, don't say that yet because you might be jinxing us. We got this. I think, am I allowed to show it to you? I don't know if I am, but Pearson, the publisher. So this site, we're partnering with Wits to distribute textbooks during this whole COVID-19 pandemic. And obviously we need to go to publishers to get the textbooks. Oh, by the way, guys, we're on 10-minute break, so 15:35 we'll start. So to distribute textbooks, but we have to go to publishers to actually get the textbooks, obviously. And so Pearson, this one publisher, sent us their list of security requirements, and it is ridiculously long. So we still have to address that problem. But if we do, then we're golden. We're golden. Because do you know what Wits's monthly operational budget is? Someone guess. How much do you think Wits spends a month to run? I mean, so Wits University. A lot. Yeah. But I think even if you just say a lot, it's you'll be shocked when you hear how much if you hear how much it is. But because Thingy announced, Habib gave like a little talk. Is this one? Oh no, Ethan, come on! It's more like that times. A lot. That times a lot. You're getting closer. That's closer. It's still more than that though. And this is per month, hey? I mean, 40,000 students is a lot. It's 300, give or take a little bit. Obviously, it'll change monthly. But Habib said 360 million rand is their monthly operational budget. I mean, it's totally ridiculous, right? Totally ridiculous. But apparently half of that comes from like student fees and sponsorships and stuff, and half of it comes from government. But they have to pay all the professors. Hey, you know what some professors earn? You know what some professors earn like per year? It's crazy. So you must see like the professor. I forgot what it's called. Professors Union South Africa. Wait, I'm not sure how to Google this. I have seen it before though. No, okay, that's the South African minimum wage. How do I find this? Yeah, but there's some union, like the Wits Union of Professors or something, and they like ensure that all of the professors who are signed on with them earn something like $1 million a year or something, which is a bloody good salary. Like that's what you would expect to earn in like a senior dev position in like Standard Bank or something. So this idea that academics are underpaid, it's true up to like doctoral level, but then if you become a prof, but remember, going into university with the expectation of becoming a professor is like going and working at Standard Bank and expecting to become CEO. You know, it's not going to happen. Like, very few people become professors. It takes very long. But once you do, you're in the money. Yeah. No, I was honestly shocked. But that's from the horse's mouth, hey? That's from Adam Habib. He gave like a little talk at some, I forget where we were, but it was at Wits one day. We were all like shocked, but actually it's totally yeah, no, the amount that Wits spends on certain things, honestly, it's insane, and Wits is actually good about it. Okay, wait, but I need to go get some water during the break. But yeah, we'll start again in 4 minutes. Okay. Do the carpets still have that weird smell? It depends on the carpets. I don't know. Wits Science Stadium is quite nice. Although the bathrooms in any place that has a lot of people are always not so great. Yeah. Cool. So we finished the easy stuff for today. This really is the most hectic content in the course, though. This particular events and delegates. Yeah, yeah, we should get started again. Let me just see, where is understanding events again? I think it's around like the 30s or understanding. No. Okay, page 40. Yeah, but also 39 a bit. But yeah, page 40 is most of it, and 41. So yeah, we are now on to page 40, 41. I know we're jumping around a little bit, but if you read through the textbook yourself, I think you would agree that the order they go in is just totally ridiculous. So yeah, now this I would say is the most difficult. These two words, events and delegates, this is the most difficult concept in the course. Okay. Luckily, you don't have to be able to code them yourself, although obviously I'm going to show you an example, a full example of how these might work, and I'm going to explain why they're used. The main thing, though, is that you must understand what they do. Okay, so yeah. Alright, and I suppose the reason we explained reference and value sort of together is because it's a bit abstract, really. They're kind of separate concepts, but this idea of pass by reference is used in events and delegates. Okay, cool. Yeah, if you don't mind, I'm going to jump right back in because we should, hopefully we can finish this today. Okay, so yeah, let's move back to object-oriented programming now. I want you to remember this line specifically. The world contains things, objects that interact with each other simultaneously. Okay, in particular, this that's now highlighted in blue, interact with each other simultaneously. This is what we're trying to replicate, right? You might be thinking, oh, well, we do that with methods, right? And yeah, kind of. We do it with methods, but you guys haven't yet seen the methods that actually do this. Okay, so yeah, you know what methods are, and you know that they can perform pretty complicated actions, right? So pretty complicated step of instructions, you can encode that in a method, and you can do some interesting stuff, all right? But there are even more, is the word abstract? I don't know. There are even more advanced, that's the word, structures that can do even more powerful things than just a standard method. Okay, they are still methods though. So yeah, kind of we use methods to do this. You just don't know what those methods are yet. And they are called events and delegates. Events aren't technically methods, but delegates are methods. Okay, cool. So to actually discuss this, we're going to set up a little bit of an example. Okay, so we've got a YouTube channel. All right, we've got everyone's favorite content creator. Okay, and we've got his more than 10 adoring fans. All right, and we want to see how does YouTube actually support this relationship. Okay, how does YouTube actually run this? So we're going to begin by saying, okay, how would we handle this at the moment? Alright, so the content creator will upload some exciting new content to YouTube. Okay, and then YouTube will somehow, well, we know how, through a method, will notify his adoring fans. Okay, he will notify the subscribers. Alright, how would we do this, and why is our way wrong, is the question we want to answer first. Okay, we know how we would do this, and we're going to program it up together now. But at least abstractly, hopefully you can see, well, we will have like a class for videos, some class that uploads the video maybe, a class for subscribers, and somehow we'll relate the video uploading to the subscribers being notified. Right? Hopefully you can see that that's sort of how we would approach this. Only if they hit the bell. Only if they hit the bell, yeah. Well, actually, that might be a good... Actually, I'm going to remember that because that might be a good way of explaining why the way we do it is wrong. Okay, so I'm going to show you how currently, with our understanding of methods that we've built up over the course so far, how we would do this, and then we're going to describe why YouTube wouldn't do this, okay, and why any large company wouldn't do it this way, okay. So yeah, let's see that. Let's clean up the main method. The first thing we need is a video class. right? Luckily, in infinite foresight, we have made a video class. Okay, so it's a class, it just has a video name, and that's enough for us right now. Okay, that's enough. We don't need anything more complicated than that. This is our video class. All right, so let's just quickly get back to the point where we have created a video object. How do we create a video object? We say video, vid, we're going to stick with calling them vid, okay, equals, because I don't want to say video too much. You could do this, video, because this is not a reserved name, okay, but I don't want to say video 300 times because it might sound strange. Okay, so video equals new video, or video vid, and we have to specify a name. Okay, so we'll say exciting new content. Okay, is that how you spell exciting? No, it's not. Hey, exciting new content. Okay, cool. So video vid equals new video, exciting new content. Okay. So, we can just make sure that our class is still working, even though we did check like 5 minutes ago, but let's just double check. So, vid.video name, right? Just to make sure that it did in fact make the video name new exciting content. Our constructor here must be working. Okay, so when I run that, bam, exciting new content, working correctly. Okay, so we can now create videos, all right? But now content creators have to be able to upload videos, right? Now, we're no longer doing this how we would do it for a school project, right? We're thinking in terms of, okay, we're this major company, we're YouTube, how are we going to do this properly? You don't just make a little upload method inside class video. That's not good enough. How programmers do this on a formal level is basically everything has a class, okay? Because if you make changes to one class, it's more self-contained. You only have to, do you guys remember the word compile from early on in the course? But we can just say translate. You only have to translate that code into something the computer can understand. You only have to translate that little bit. If you do everything in like one long method, then when you change one thing, all your code has to be updated and your whole site has to be updated, and that's a huge nightmare. So you only have to change little bits if you compartmentalize things like this. Okay, that's the architecture word, right? Compartmentalize. You want to have small rooms, right? So if something goes wrong, only one room is affected. You don't have to fix the whole building. And it's the same idea here. Okay, so our video uploader, okay, the thing that uploads our videos is going to be its own class. Okay, so let's create our video uploader class, all right? Class, yeah, let's make this not public anymore because we don't want to have to think about that. So class, we'll call it our video uploader class, video uploader, like so. Okay, pretty cool. Class video uploader. And then this is just going to have, yeah, we only needed to have one method, okay, an upload method. So it just needs to upload our video, okay. So what will this method be? Let's say it's public, okay, it's a public method. We want to be able to access it outside of video uploader. It won't return anything. So yeah, public void, we can call it upload. Okay, so upload the video. What will this take in? What will our upload method take in? Does anyone have any suggestions? In order to upload a video, what should our method take in? Bear in mind, we're doing this super simply. Is it going to take in an int, a string? What should we do? What have we seen today that would be a sensible thing for the upload method to take in? Okay, no one's getting it. So we're going to make our upload method take in a video. Okay, it's going to take in a video. The video to upload. Everything else we'll say is sort of self-contained. So it's going to take in a video vid. Okay, This shouldn't be shocking to you. We just saw this now, right? You can pass an entire object to a method. Okay, so we've got our video uploader, and let's say this is just going to upload the method. Again, we don't care about the technicalities of how this is done. We want to see the overall structure of how this would work. Okay, so this will say uploading new video. Cool. Okay, so we've gotten a thing that will upload the new video. So we're kind of, if we look at our slide, we're working on this bit here, right? How does the content creator create a new video and upload it? Okay, we haven't started thinking about notifying subscribers yet. We're just thinking about this idea here. Okay, so we've got upload, some code to upload the video, and yeah, let's see if this works. So we need to create a video uploader. Okay, so we've created a vid object, a video object. We need to create an actual object of video uploader. So video uploader, we are gonna call it video uploader. Or let's just call it uploader. That's easier to type. Video uploader equals new video uploader. Wow, if I manage to get through this whole event delegates thing without a mistake, I'm going to be quite impressed. Okay, so video uploader equals new video uploader. Okay, so we've now created the thing that will upload the videos for us. Okay, so now we actually have to upload the video, right? So the upload method is the thing that uploads the video. Okay, uploading new video. So let's call that. How would we do that? We just need to say uploader dot upload, and you have to give it, what does it expect? It expects a video, right? So we have to give it a vid. We have to give it a video. We're going to give it vid, okay, because that's our video object. Okay, so when I run this, it just prints out uploading new video. Okay, so that's one part of our process done. Okay, yeah, sort of. We're almost there. We should kind of have some notifier that goes, okay, uploading new video, and then when the video finishes uploading, it must go uploaded or video uploaded or something. You want to tell the content creator that the video has finally been uploaded. Okay, so let's create that. Let's create that. Where am I going to put that? I'm quickly going to introduce you to an industry standard because it will come up later. Okay, we're going to create another method that goes, okay, when the video is uploaded, just call me and I'll handle all the logic about notifying the creator that the video has been uploaded. Okay, so we've got our upload method, and now we're going to create another method. So you might call this like public void uploaded, right? Past tense, uploaded. Okay, so the idea is like, okay, so the video was uploading in the upload method, and when it finishes uploading, you can call uploaded, and everything that needs to happen after the video is uploaded will happen there. Okay, I do just want to say, because even if I was in your position right now, I might be thinking, wow, this seems like a lot of effort for a simple example. So, number one, this is the only way. This is pretty much the simplest way I can show you events and delegates. But two, let me think. Yeah, this is setting it up in an interesting way. Okay, so we will do it this way. Okay. I sort of lost track of my thought there. Okay, so uploading new video. Okay. After the video is uploaded, I just want to call uploaded. Okay, because the video has been uploaded. Right, not too bad. And then inside uploaded, that's what I wanted to tell you guys. Okay. So yeah, you might be thinking like, wow, this is a lot of setup for this example, but yeah, this is the only way we can set up the example. And yeah, secondarily, what I want you guys to picture is this line here, this uploading new video line. Obviously, it's an oversimplification. Okay, obviously it's an oversimplification. So what I want you guys to appreciate is that this would be replaced with a huge amount of code, right? Like actually uploading a video, you would be surprised how difficult that is to program. Okay, like to do something like that securely will take hours and hours and hours of like very, very good developers working on it. Okay, and like on, and even a method like this, just a method that notifies everyone after the video has been uploaded, all of the different errors that can occur, all of those different things that have to be pointed out, like, you know, is this video made for kids? Is it you know, advertiser friendly? All of these kinds of things. There's a lot of work that goes into creating a method that simple. So our methods here are very simple, so you might not be able to immediately picture like, why do I have an uploaded method? Okay, but what I want you to appreciate is that that method could be way more complicated than we're making it here. Okay, so I'm just giving a simple overview of maybe how the flow of a video uploader would work. Okay, so yeah, just pointing that out. Okay, so our uploaded method is just going to print like video uploaded, okay, or finished uploading. Let's say that, finished uploading. Okay, and this, guys, it is a lot. This is actually the largest program I've shown you, and so yeah, that might be a bit scary because you're seeing like this whole wall of code. But understand, guys, there is nothing new here. Okay, there is nothing new here. We just created two classes. Okay, our one class has a public property. You know exactly what this is doing. Okay, it has a constructor. You know exactly what that is doing. The other class just has two methods. Okay, this method just prints out uploading new video when you call it, and it calls another method, uploaded, and that method also just prints out finished uploading. Okay, very simple methods. Okay, so it is like there's a lot on the screen, but understand there's nothing new yet. Okay, so I don't want you to be worried yet about what's going on here. And also, I'm going to make this code available to you after the lecture through Rex Tester, so I'll share it with you. So if you're worried, you can just go through it. Okay, and then yeah, also the other thing to remember, this is the hardest part of the course, guys. This is the hardest bit. Okay, cool. So now when I call uploader.uploadVid, it's going to print uploading new video. After it's printed uploading new video, it calls uploaded, and then uploaded just prints finished uploading. Okay, so now when I run this, you can see it prints uploading new video, and then it prints finished uploading. Okay, cool. So now in our slides, we've done this little bit, right? A content creator can go and create a new video and give it a title. That video will be uploaded, and after it's uploaded, the content creator is notified. Okay, now we want to think about this other idea. Okay, and what I want you to see is already, even though we are doing this in a amateurish and wrong way so far, because we don't know what events and delegates are, I still want you to appreciate how the classes, how this whole class structure is allowing us to separate these two ideas, right? So we have this idea of videos and content creators, kind of, and we'll have this subscriber class, but you can see that they're very separate. Okay, if I want to change subscribers, I don't have to change videos. Okay, and that's why this object-oriented programming idea is so popular. Okay, cool. So let's now think about this other idea. When we've uploaded a video, we want to go ahead and notify subscribers. Okay, we want to notify the subscribers that a video has been uploaded. Okay, we're not going to be doing bell things yet, but maybe you can see how would you implement that. You might have an if statement, right, to say if the bell is hit, for example, then only notify. But for now, we're just going to notify our whole subscriber class. Okay, and actually we're not even going to do that. We're just going to print out notifying subscribers. Okay, or yeah, something like that. Okay, so we've got our video uploader class, we've got our video class. In order to notify subscribers, we need to have subscribers, obviously. So let's go down to the bottom of our code here. Also, guys, the order of the classes means nothing. Okay, C# doesn't see it. As long as all the names are correct, the order doesn't matter. Your subscriber class can come first or anything like that, so don't worry about what order the classes are in. Focus on what they're doing. Okay, so we can say class subscriber. Okay, and this again will be nothing new. I know the code is becoming a lot. But actually, it's also nice to be able to see, like, maybe you think this structure looks very simple, right? You would think, wow, this is such an easy thing to do. But no. No. Yeah, and there is this nice divide in, like, the business world. So, like, even if you aren't planning on becoming a programmer one day, maybe you will be able to appreciate a little bit more, because there'll be tech people who will go, hey, I've got this amazing idea. I mean, business people who will go, hey, I've got this amazing idea, like an application that can automatically classify different bird species, for example, like a mobile app. Not realizing, like, oh, wow, yeah, that would take a university of like 300 academics 2 years to create an application that can classify all these different bird species, right? Thinking that it's just a little business project, okay? So maybe you can start appreciating, like, actually these simple ideas are very complicated to actually create. Like, even this, our little video application platform, Cisco, huge mission to create something like this. Took years of work, definitely. Anyway, but getting back on track, we're creating a class subscriber. Okay, a subscribe class, you're used to how classes work by now, I hope. And this is also just going to have one super simple method. Okay, public. For now, we're going to make it static, which means, what does that mean again? I'm going to remind you one more time. Static means I do not have to create an object to call that method. Okay. I do not have to create an object to call that method. I know I'm rushing through this whole class definition, but please, we're going to be spending a lot of time with it. Okay, so public static. Okay, so we've got our little method that will be changed later. Void. Okay, this is just going to be called notify subscribers. We'll say subs for now. Okay, notify subs. Okay, so we've got a little method that just notifies our subscribers, and this is literally just going to print out console.writeLine. Console.writeLine. A new video has been uploaded. Exclamation points. Okay. Cool. So we've got this basic structure going. Okay, cool. So how would we do this now? We've created a subscriber class. Okay, so we've got the more than 10 adoring fans down. We just need to actually figure out this notify subscribers bit. We've created the notify method. Okay, so it notifies the subs. But where do we call it? Okay. So I want you to see that there is a divide here. Okay, so here in the finished uploading method, right? So in the uploaded method, here where we go finished uploading, ideally we would want to put it here, right? Because we want to go, okay, there, as soon as the video finishes uploading, it's a part of the exact same logic. I now want to go and notify the subscribers. Okay, as soon as the video is finished uploading. Okay. You might also think that actually we could put it here, right? So after we call upload vid, then we create a separate call to notify subscribers. Okay, so you're cool that it could go in either place, all right? For now, because it's closer to what should be happening, I'm gonna put it in here. Okay, so right here. I'm not sure if we'll have to make it public class subscriber to put it here, but I think this will get the idea across better when you start seeing the proper way this should be done. So yeah, let's try it this way. I'm going to say subscriber. Okay, where's subscriber coming from? That's the name of our class. And I'm going to call this method .notify subs. Okay, .notify subs. Okay, and when I run this, it works. Okay, so we say uploading new video, finished uploading. You probably heard I was surprised as you are there. A new video has been uploaded. Okay, cool. So all I've done, I know it looks scary, and we're going to go through this version of the code right now together. But all I've done is program up this little structure here. Okay, so you create a video, you give it a title, you call the upload method, and that uploads it. The upload method just prints that it's finished uploading. Okay, when it's finished uploading. Okay, and it also calls a method to notify all of your adoring fans. Okay, cool. That's all this structure does. It might look freaky, but there's nothing new here. Okay, I know, and you can start to see as well, when code gets complicated like this, ideally we would want to start splitting things into different files, right? Because even though all of this stuff is familiar to you, even I get scared looking at just a wall of text like this. Okay, but hopefully each component, each class, I want you to understand individually. Okay, for now. Alright, so cool. So what happens? Let's just go through it exactly like we just went through the diagram. Alright, so we create a new video. We give it a title, exciting new content. Okay, so what is this doing? It's just creating an object of type video. It comes to this class. Alright, this class has the property video name, and it just sets that property to whatever name you specified. Okay, not too bad. That's just what a constructor does. Right, that's the most basic class example I could possibly give you, and that's just creating an object of type vid. Okay, we've got video uploader equals new video uploader. It's a bit of a mouthful, but all that's doing is creating an object of type video uploader. Right? We then call a method inside video uploader, okay, called upload. So we just go find that. Okay, upload. We have to give that a video vid. Okay, we have to give that a video to upload. It goes okay, and we gave it vid. Okay, that the video object we constructed on the first line, we just gave it that to upload. Okay, and that came in here, video vid. All right, that just prints out uploading a new video. Okay, with that idea, and then it calls another method that handles everything that happens after an upload is finished, and that's just called uploaded, past tense. Okay, public void uploaded console.writeLine. That all that does is print out finish uploading, and then it calls a class called subscriber to notify all of the subscribers, and that just prints out a new video has been uploaded. Okay, notify subs just prints out a new video has been uploaded, and so that is just this process here. That's how you would, and in like a professional context, you would split it into those classes. Okay, everyone happy with that structure so far? So in the next 27 minutes, we can explain why it's wrong and how we can fix it. Okay, so there's a few reasons why this is wrong. Ethan brought up one, but in order to, well, he might not have known that he was bringing up one, but he did. But before we get into that, let's think about there is a simpler reason why it's wrong before we get into that one. So currently, if picture yourself as a developer at YouTube, okay, and you've got this structure going, okay, this video uploader, and your boss tells you, all right, please go and update the video uploader. Okay, just go update the video uploader. Okay, and you go, okay, cool. And he says specifically, focus on what happens after the video is uploaded. I want you to change that in some way. Okay, now as a developer, when you're going and changing a video uploader, do you want to think about subscribers? No, right? When I'm uploading the video uploader, as a human, I think of this as a self-contained thing, right? This uploads videos. That's what video uploader does. Subscribers are a totally separate concept. I'm not even thinking about how these two things are related. But you can see here, they are clearly related. if you change this method, you're changing a lot of other stuff about the site. Okay, you're not just changing the video uploaded, what happens after a video is uploaded. Likewise, if you came here and changed the subscriber model, like if you the class, and you just changed this notify subs, like one day you were saying, oh, that's not a good name for this, it should be notify subscribers, right? Can I even spell subscribers? Subscribers, that's it, right? Yeah, it should be notify subscribers. Okay, and you would think, okay, I just changed the name of the method. This should not impact the video uploader, right? The video uploader shouldn't care about the name of the method inside my subscriber model, inside my subscriber class, right? It wouldn't make sense for it to. Okay, but you can see how we've done this currently. If we change notify just the name of this method, we now have to go and update this class, right? And now picture it, if you're a developer, right, at YouTube, for example, there's millions of lines of code at this organization, and you're changing the subscriber model. How are you, as just like one of the hundreds of developers that Google employs, how are you supposed to know that, okay, I've changed the subscriber class, I now have to go and update the video uploader class, right? You might not even have permission to upload the video uploader class, right? So the idea of events and delegates is like, how can I make this self-contained? Updating subscriber should not require me to update video uploader. Okay. Now this might seem like a really abstract idea to you guys so far, but yeah, it is super advanced. But it is a part of the course, so we must cover it. And yeah, it's very cool that you guys are learning this already. All right. But anyway, okay, we've got 23 minutes left. I do want to get through this. Okay, so hopefully already you can appreciate why this is totally wrong. Okay. And for Ethan's example, so currently we've got this subscriber class, right? We've got subscribers. What if I now want to add the idea that if you hit the bell, you must receive extra notifications? Well, then maybe I would add another class, right? So I'd add a class bells or whatever, class notification bells. And so I'd add a class notification bells. And now if I wanted this class to actually work when a video was uploaded, I have to go and update the video uploader. Why? Why do I have to upload the video uploader just to add a totally separate thing? Okay, so that is in fact the reason events exist, so that you don't have to. Okay, so let's talk about how events work. All right, I hope you guys aren't too freaked out. But yeah, this is tough. It's a very abstract idea. Okay, cool. So we've got this structure. Okay, and we now know why it's wrong. Alright, so how do events fix it? So let's remove everything that we've done so far. Okay, so we just have this thing that notifies the subscribers. We've got content creators that can upload videos, and we've got subscribers somewhere. Okay, so now what we do, how we add events and delegates to make this better, is we put a messenger here. Now, messenger makes it make sense, but obviously programmers had to obfuscate or make this slightly more confusing, and so they don't call it messenger, they call it delegate. Okay, but it means the same thing. I don't know if you've ever heard like in the news or something, like the US delegate visited India or whatever. All a delegate is like a messenger or a negotiator between two parties. Okay, that's all a delegate is. That's what the word means. All right, or at least something like that. Okay, so delegates, right? And all we do with this delegate is we give them an ear. Basically, we say, okay, you are going to listen for a specific event to occur. Okay, so I'm going to tell you what to listen for, and if you hear it, then I'm going to tell you what to remember. Okay, so we like really lay out, like, this is the event that you are the delegate for. Okay, this is how like what you must be listening for. Okay, and we also tell the delegate how to communicate to notify subscribers, but we'll get to that later. Okay, the primary thing, we tell the delegate what it must listen for. Okay, so now a content creator goes and uploads a video. Okay, uploads exciting new content. Okay, and then instead of notifying subscribers directly, calling this directly, what we do is basically like shout. Okay, we go, I uploaded a thing. Anyone who's interested, you can listen. Okay, you just blurt it out. Okay, it seems very unelegant, but it works much better. Okay, so we just shout out, I uploaded a thing. The delegate hears this. This is what it was listening for. Okay, it's listening specifically for this, and it just goes and informs notify subscribers. Okay, and notify subscribers goes ahead and notifies the 10 adoring fans. Okay, looks a bit weird. But we'll see an example now. Okay, but yeah, the idea is, the primary idea here is actually the delegate. Events are pretty simple actually. Okay. Yeah, remember, this is the toughest part of the course. Okay, and we're on page, you can see how they explain this in the book is just terrible, actually. It's really, really terrible. Okay. Cool, so okay, what are we doing? All right, we want to actually set up this example now. Okay, so we need a delegate. All right, we need YouTube or our video uploader to now shout out to notify people when a video is uploaded, and what we would call this is an event, to notify people of the event. Okay, and we need to tell delegate how to communicate to notify subscribers. Okay, so I'm going to set this up now in the last sort of 18 minutes. And yeah, I'll go through it sort of in as much detail as we can. And I also found another nice video, because I was very worried about how I was going to explain this idea to you guys, because it is very... it's very abstract. It's very advanced to be learning in like a introductory programming course. Okay, but yeah, let's begin setting this up. Okay, but we've seen what we need. All right, so we need a delegate. Okay, a delegate like a messenger. All right, we need an event. Okay. And we need to sort of, the word they use is raise. Let's say call or use the event. Something like that. Use the event. Raise the event. Yeah. Okay. So these are the 3 steps we need to follow. All right. Yeah. These are the 3 steps we need to follow to set up this structure. Okay. And most of the changes will be happening inside Video Uploader. Okay. Now, some other quick changes that we have to make, or not have to, but it's a good standard. Here we call this uploaded. I'm just going to change its name to on uploaded. Okay, on uploaded. Usually, that is how we refer to something that is going to call an event, that is going to shout out an event. Okay, you can see it a lot in HTML code. It's how buttons work. Okay, so you can see the buttons on my screen here. When I hover over it, there is a method, and if you right-click and click View Page Source, you would be able to see it. It would be a mission to find, because there's a lot of stuff going on, obviously. But it will the method they will use to do this is called onHover. Okay, so I'm hovering over the button. So there's a method called onHover, and when I hover over the button, it's just programmed to change this method. All it does is change the color of that button just a little bit. Okay, and we usually call these things that happen at certain events on something. Okay, so our one is going to be called on uploaded. So when something is uploaded, on uploaded, this must happen. Okay, all right. Not a big change. I just changed the name of the method. I'm just I just wanted to explain why I did that. It's not like arbitrary. Okay, how do we create a delegate? We say public delegate. It's a method. It's void. Okay. So this delegate keyword, that's just the word that they use, all right? And you can think of it as a messenger. Okay, a messenger between events and subscribers is what we would call them. Okay, we'll get into those words later. Okay, cool. So public delegate void. Okay, and you can see on page 40 there is a standard way to name delegates, if they even show it. Yeah, you call them handlers. Okay, why they use both words? Please, guys, don't shout at me about things like that. Why they use all of these different words for these different things is totally beyond me too. Okay, but we call delegates handlers usually, and how they're named is we say the sort of event they're controlling, uploaded, right? And then we would say handler. Okay, something like that. Cool. Uploaded handler. Okay, so now don't worry too much about the technicalities of what this is doing. We're just creating a special method of type delegate, or that is like a delegate. But think about it like this instead. Okay, it's just something that's going to listen for an event to take place, and it knows how to listen. It knows what to listen for. It knows what to save. Okay, and it's just going to be like the interface between this and the rest of our methods. Okay, cool. So uploaded handler. Wow, okay. Cool. We then have to create the event. All right. This you could see on. Geez, no, they literally just don't give an example. That is such a pity. Again, no, their example is terrible, so just let's not think about that. Okay, so, but it is hypothetically on page 41. Okay, so we say public events. Okay, uploaded handler. Okay, so what are we doing here? We're saying, okay, this is an event, and it is listened for by particular delegates. Okay, so it's not just the delegate that listens for a specific thing. The event has to shout in a particular way. Okay, so we're saying this event shouts for these delegates. Okay, and then we just say uploaded. Okay, so that's our event, an uploaded event. Are you guys still? There really is no other way to explain this, and it is a very difficult concept. So I really do feel for you guys now. But yeah, I really do feel for you guys now. But hopefully I'm making it easier. But we can. But we'll see. We'll revise this a lot, and I'll send you some other resources as well. And you'll be able to go through all of this code yourself as well. Okay, so this event, the uploaded event, shouts for these delegates. Okay, so we're saying this uploaded handler is the messenger for this event. Okay, and now in onUploaded, instead of going and calling this subscriber, we simply call uploaded. Okay. Yeah, we simply call uploaded. I can't believe I used the word simply there, but I did. Okay, so all this is saying is, hey, look, an uploaded event happens. So literally what this is doing, this uploaded bit here, is just shouting. It's doing this. It's going, I uploaded a thing. Okay, and every delegate of every delegate of type uploaded handler will hear that shout. Okay? Cool. And now there's just one more step. So, let me now give you the reason we use the video example for this is it's quite nice. I'll now, can delegates communicate with other delegates? Can delegates communicate with other delegates? No, and you'll see why now. Okay, you'll see why now. I'll make sure I'll remember to point it out as well. Okay, so cool. So we have our little messenger, but the fact that you're asking questions like that is probably good, because that's a good question to have right now. I'm glad it's not like, what the hell is going on? Okay, so a shout happens, the delegates listen for it, and now we just need to say, okay, everyone who's interested in listening for this, all the delegates who are interested, okay, you now need to start listening. Okay, how we say this, okay, what we call this, a method that does the shouting, okay, something that has an event. This is called a publisher. Okay, a publisher, because they're publishing an event. So you can think about it like it goes, I uploaded this thing. It's publishing this event. Okay. The delegates that listen for a particular event are called subscribers. Okay, are called subscribers. So what we need to do now is we need to take our subscriber class, okay, and we need to tell it that, okay, you are subscribing to this event. Okay, so when this event occurs, you need to change. Now, guys, what I want you to think about here is it's actually really, it's really powerful what's going on there. Okay, I don't want you to just take it at face value. Like with this button here. Okay, it's actually quite interesting what's going on here. The mouse goes over the button and it says, hey, I'm over something. And all the buttons go, oh, is it me? Is it me? Okay, is it hovering over me? And this is kind of like how the relationship is working. Okay, so like all the delegates are permanently listening for an event, and if they are specifically, if the thing they're specifically looking for happens, then they go, would a delegate be not so you'll see what goes on now. Let me finish setting this up, okay, and then we can, in the last 5 minutes, go through it in more detail. Maybe we can go a bit over time for people who have time. Okay, I'm quickly going to create a object of type subscriber. Okay, because we now need to make subscriber, our subscriber class, subscribe to the uploaded event. Okay, so we need to actually do this. So I say subscriber sub equals new subscriber. Okay, so I'm just creating a subscriber object. We're used to that. And I now need to tell it to subscribe to the uploaded event. Okay, how do I do that? All right, we've got our uploader here. All right, so the uploaded events, here it is, public event uploaded, handler uploaded. It's here, right? We need to say, okay, go inside uploaded. All right, inside uploaded, uploader. So inside our object, uploader.uploaded, so that's our event, right? Uploaded is our event. Plus equals, the other way of saying this is uploader.uploaded equals uploader.uploaded plus. Okay, let me just write it out the simple way first, and then I'll write it out the way the book writes it out. Okay, so we say uploader.uploaded equals uploader.uploaded plus the new subscriber. Okay, sub dot, what is our new subscriber? Notify subscribers. Okay, sub dot notify subscribers. Okay, like that. I'm gonna change this back to notify subs. No, it's fine. It doesn't matter, right? you guys can see what's going on, right? So now the simpler way of writing the same thing, instead of saying, and it works the same with numbers, okay, let me just remind you. So instead of saying int x equals 6 and then saying x equals x plus 2, okay, instead of saying that, it's equivalent to just say x plus equals 2. Okay, and you can do the same thing here. So instead of saying uploaded.uploaded plus sub.notify subscribers, we can just say uploaded.uploaded plus equals sub.notify subscribers. Okay. So hopefully you get that little shortcut. It's just a shortcut. It means the same thing. Okay. And then, finally, we are done. That is how you would do this professionally. Okay. That is how you would do it professionally. Oh, and this doesn't need to be static anymore. Okay. Because now we've actually created an object of type subscriber. But don't even, I don't even want you guys thinking about static now anyway, so I don't know why I mentioned it. Okay, now if I run this and I didn't type anything incorrectly, it works. I am shocked that we did not get an error there. That's why you guys should prepare for presentations, okay? I am shocked that we didn't get an error there. Anyway, good thing, so this works. It does exactly the same thing as it was doing before we did all of this work. Okay, it does the exact same thing as the previous way we did it. Okay, if you can even think back to the previous way we did it. But now this is implemented with events and delegates. Okay, so now if I create another class, okay, let's create class bell notifications. Okay, we'll call that bells just for short. Okay, class bells. And then we say we can copy paste this method. Okay, pretty much exactly the same as the notify subscribers, except this time we're not notifying subscribers, right? We're notifying subscribers who have hit the bell. Okay, it's slightly different. It's only slightly different, but we can see. So we'll call it notify bells. Okay. And we'll just say this one will just print out notified. Okay, so now previously what we would have to do is, in order to notify the bells after a video is uploaded, we would have to come and edit this on uploaded video. On uploaded method, right? Now instead we just say, we come back to the top here and we just say, okay, we just create a thing of type bells, bell equals new bells, and we just say, oh, by the way, uploaded, you have another subscriber. Okay, bell dot, what was the method called? Notify bells. Bell dot notify, oh right, it brings it up automatically. Bell dot notify bells. Hopefully, if I recall, it should work on one line like that. Ooh, sorry. Oh yeah, okay, cannot be applied twice. Okay, so we have to do it on 2 lines. This is why shortcuts aren't always the best thing. Okay, so the reason it's complaining is just that we have to do it like that. Okay, but we're just saying basically, uploaded, you have another subscriber now. Okay, and then bam, it will notify the other class. Okay, so you see now it prints out notified as well. So now it's coming to this bells class as well. Okay, cool. So that's events and delegates. I imagine you might have to watch like the last 30 minutes of this again, or perhaps I'll send you another video as well. That was pretty helpful for me. Although the video that I'm going to send you it goes into sort of more technical things. Like there are some other stuff. So maybe stick to this first and revise from this first and then revise from that. Okay, but I'll send you the code that we just wrote as well, or send you a link to the Rex tester wall for this code. And now we will be going over time a bit, but maybe I can get to these 2 questions. So you asked, can delegates communicate with other delegates? No. Right? Why? Because in order for a delegate to actually do anything, it needs to be linked to an event, right? So you see here I added it to an event. you couldn't really like add a delegate to a delegate or something. It wouldn't work. Okay. The next one was, so would a delegate be similar to an if statement? So certain things like this, for example, you could put in an if statement. Okay. Let's actually, Alex, this is a good question. This is another reason why events are so clever. Okay. So let's say I was programming all these buttons. Okay. You see all the black buttons, they do the same thing when I hover over them. And all the blue buttons also do a similar thing when I hover over to them. This red button also does the same thing. Okay. This, when I mouse over them like this, when I hover over them, it's the same event that's being called, right? So so let's say I had these methods for all 7 of these buttons. Okay. And I was doing if statements. I would have to have 7 if statements. And then I would have to go, okay, you need to increase your opacity to like 0.75 or whatever. They usually change. It's just changing. You see it's like dimmer and then darker. So they're just either changing the tone or the opacity. It depends how they decided to do it. But whatever, there's some set change that all of them do, right? If I had to add an if statement, I would have to do that 7 times, okay? Whereas with an event, I just say, hey, this button subscribes to this event. This button subscribes to this event. This button subscribes to this event. Okay, so I'm just saying all the buttons subscribe to the event, which will just be as simple as going plus on handler or whatever. Okay, plus on hover, I mean. And then all of them change in the same way. Okay, because it's the same events occurring a lot. So I only have to program the event once. Okay, so certain things, it's not just easier to do. Okay, the event is like in some cases you could do with an if statement, because here you could say if on hover do this, but you see in this case the event wasn't replacing, in our example the event wasn't replacing an if statement, right? It was replacing this function call, I mean this method call, whatever you want to call it. It was replacing this call here. Instead of calling this directly, I just shouted to the event. Okay, so it's not always just checking a condition. Okay, it's more like, I really think about it in terms of publishers and subscribers. Okay, so I can do something. I say, look, anyone who's interested, I just did this. Okay, and everyone who's listening now knows that I did that. So if they have to do anything depending on that, then they now know. Okay, so it happens in this parallel way. Okay, so don't think about it like an if statement. The if statement is just checking one condition. Okay, this isn't necessarily just a condition. It handles like flow and it can do things simultaneously. It's a much more powerful, much more advanced idea. Okay, but in some cases, what you would do with an if statement, you could do with an event in a certain way, but it's they're different ideas. Events are much more powerful. Okay, or I mean, if statements are also very useful and are used more frequently, but they're separate ideas, so don't conflate them too much. But like you can think of it in a conditional way. So it's sort of going like it waits for this to happen and then it does it. Okay, but it's like, think about it in terms of this graphic here. Okay, like I wouldn't display an if statement right like this, right? I wouldn't display an if statement like this at all. So yeah, think about it in this way. Okay, cool. So if will we be doing more examples on this? Maybe 1 or 2. I think in future, if we cover this again, it will be like this. Okay, it will be in this theoretical way, because that's more relevant to the type of questions you're going to be asked in the test. Okay, I'm going through this example like this now. It's nice for your learning, I think, and I do prefer teaching the concepts in full rather than just teaching towards the test. But with something that's as difficult to explain as this, like going through another full example would be too time consuming. There's a lot of material to still get through. So we'll go through it on a theoretical level, definitely, but don't expect another fully worked example like this maybe way later in like a crash course revision session we might do it, but yeah, don't expect it anytime soon. Okay, cool guys, so that is events and delegates. Honestly, that's the hardest section in the whole course. Okay, so if you're feeling pretty comfortable about this, obviously do revise it still, because there's a lot of little tricks. Okay, but yeah, and I'm also going to send a video and I'll share the Rex tester code as well. But yeah, we can call it there. We already went a bit over time, so I'll see you guys next week. Same time, maybe different place, I don't know, I'll let you know. But yeah, cheers everyone. Yeah, you too. No problem everyone, bye bye.